following presentation has been put together to help educate and train managers who are responsible for employees who have been maybe exposed to hand-arm vibration and to have invested in Reactec's HAVwear device to help them manage the risk to their employees of exposure to hand-arm vibration. The presentation also covers the use of the same equipment for the purpose of maintaining social distance between employees. So this is a functionality, if you haven't already acquired the kit for this purpose, can be switched on at any time, and so is covered in the second part of this presentation material. This presentation material is identified as Part A. It principally covers the reasons why you would want to invest in Reactec's technology to help with the management of hand-arm vibration exposure or social distancing in the workplace, and touches only lightly on how the equipment works. A second follow-on to this presentation, identified as Part B, goes in a lot more detail into how the equipment should be used to best manage exposure to hand-arm vibration and social distancing if you're also using for that purpose. Hand-arm vibration syndrome is an overarching medical term to cover the damage that can be caused to the hand from exposure to vibration. There are three types of specific damage: neurological injuries, vascular injuries, and musculoskeletal type injuries, which can result in a loss of grip strength, severe pain and numbness in the fingers, pins and needles, and a loss of the sense of touch. Within the ISO standards on the topic of the human response to vibration, there is a correlation of the likelihood of developing the symptoms when exposed to certain levels of vibration. And this relationship between exposure and outcome, or health outcome, has been developed looking at the vascular side of the possible damage only. And with that consideration, it has been said that 10% of employees exposed at the action value, which I'll explain in due course, if you're exposed to that for a period of 12 years, then there is a 10% probability of developing the vascular damage or white finger. If the exposure is as high as the limit level, then that period drops to only 6 years to have a 10% probability of developing the vascular damage or vibration white finger. Exposure to vibration is the cause of the top RIDDOR, as reported most recently to the Health and Safety Executive. The statistics here are shown for 2018, where hand-arm vibration syndrome RIDDORs are about 43% of all the data shown, with the second highest reported disease, carpal tunnel syndrome. Carpal tunnel syndrome is another type of damage that can be caused by exposure to vibration, but there are potentially other causes of carpal tunnel syndrome. The legal requirements with respect to hand-arm vibration syndrome are laid out in the Control of Vibration at Work Regulations 2005. They require that an employer reduce the risk as low as reasonably practical, but also require that an assessment of the risk is carried out on a regular basis. Now, a suitable and a sufficient assessment of HAV exposure risk requires a determination of two pieces of information. First of all, the duration of the exposure, and secondly, the probable vibration magnitude during that exposure. And I'll explain why the term probable comes into play in this piece of guidance or information. The HSE have developed a Ready Reckoner to help quantify the two factors of time and vibration into a singular scoring system and relate those two to the two thresholds described earlier of exposure action value and exposure limit value. So any combination of time and vibration magnitude can result in an exposure point. And your exposure points from use of multiple tools in any one day can be simply added together and compared to the thresholds of the action value and the limit value. So for instance, 3 hours use of a tool with a vibration magnitude of 5 meters per second squared will result in exposure points of 150, which is above the action value. So the action value, which is a value of 100 points, could be achieved from the use of 8 hours of a tool at only 2.5 meters per second squared. The guidance from the HSE for people exposed to a daily level of 100 points is that action should be taken to reduce that exposure, and also that those individuals should be given regular occupational health assessments. The exposure limit value, which is 400 points, and this can be achieved by an exposure of 8 hours to a tool with a vibration magnitude of 5 meters per second squared, is a level at which the HSE advise that no one should work above, and no one should knowingly put anybody to work who will be exposed to this level of vibration exposure. One thing to note in terms of this point system for quantifying exposure to hand-arm vibration is that the points are directly proportional to time. So as the time moves from 1 hour to 2 hours, twice the time, you can see that the points double basically all the way up the scale. By contrast, the points are proportional to the vibration magnitude squared. So in the example given for EAV and ELV, it's the same amount of time. The vibration magnitude doubles from 2.5 to 5 meters per second squared, but the points goes from 100 to 400 points because it's directly proportional to the vibration magnitude squared. So given the rigorous statistics that were presented, hand-arm vibration syndrome is an ongoing risk within many workplaces. So we ask the question, why might it be that there is a continued prevalence of the disease? First of all, the source of vibration magnitude or the probable magnitude to be used in risk assessment is often questionable, particularly if companies use manufacturers' data. And the next slide will explain more on why this is an issue. Also, your risk assessment that you might carry out in advance of work being done, using some general vibration magnitude number and some assessment of the likely time of being involved in the activity may not actually be appropriate relative to the work that's undertaken. And again, there's a slide to come which will give you information on how that may be the case. Thirdly, the effectiveness of the controls. Ultimately, the requirement on hand-arm vibration exposure management is to control the risk as low as reasonably practical. Ensuring that your controls are effective requires a good knowledge of the situation before and after the introduction of the controls. Reactec believes strongly in using data to drive the design of your controls and data to assure that your controls have been effective. One of the largest variables in affecting the exposure risk of any one individual is their competence in using a tool. And again, it can be a challenge in knowing exactly how competent someone may be at using a tool. And hopefully, again, Reactec will be able to show you how they can be able to help you determine an operator's competency in any one tool. And lastly, another major variable in the vibration magnitude experienced by any tool operator is the tool that's selected for the job, whether or not it is the right tool, the condition of that tool, but also how the condition of the consumables or the bit ends used with that tool. And once again, these are variables that with static assessments or generic risk assessments or the use of single data points for vibration magnitude, it's very difficult to actually understand how much these factors do come into play. So to help explain how variable vibration magnitude can be, the following graphic is data that was published by the HSE in their guidance documents. It's since been replaced by an Appendix 3, which simply lists the tool vibration range information, but we found this graphic perhaps more illustrative. So in the graphic on the left-hand side, first of all, we have the results of the HSE laboratories carrying out evaluations on 3 different tool types. And for those 3 different tool types, as illustrated with the red bars, the HSE were able to measure a range of different vibration magnitudes depending on what they were using the tools for. In all cases, the tools were used for appropriate purposes. So in the case of the impact drill, the vibration magnitude ranged from 5 to 16 meters per second squared. The chipping hammer from 10 to 26 meters per second squared. And again, by way of illustration, if you were to use that chipping hammer at the bottom end of the scale for 30 minutes, the exposure risk is 100 points. Whereas if you were to use it where the vibration magnitude experience was at the top of that range, then for 30 minutes, that would result in 700 points. And again, given the relationship that was shown earlier on the relationship between the vascular damage and exposure to vibration, then if you were exposed at the bottom end of the scale consistently, it would take 12 years to have a 10% probability to developing HAVs. If you were using it at the top end of the scale, that 12 years would reduce dramatically to only 4. Also shown in this graphic from the HSE is the declared emissions from the tool manufacturers, which is marked on the left of the red bars, a little mark on the left, and on the right is the mean of all the measurements taken. So you can see in the case of impact drill, the declared value is very similar to the mean of the measurement taken by the HSE labs. In the case of the chipping hammer, the declared number is very much towards the bottom end of the scale, and in the case of the rock drill, it's off the scale. Now, why should this be possible? It is possible because the way in which manufacturers are required to declare the vibration magnitude of a tool is under very strict and very precise laboratory conditions. And those laboratory conditions may not then be representative of how you choose to use the tool or how a tool is used in reality. So what is the purpose of the declared emission tool? It's seldom that its purpose is to be suitable for a risk assessment. Again, the HSE very much advise people against doing so in their L140 regulation document or guidance document. But as is illustrated with the inclusion of the graph on the right-hand side, where 3 different chipping hammers are compared between 3 different suppliers, if you were to look at the declared values with the marks on the right-hand side, you would conclude that A and B are very similar tools, whereas chipping hammer C is distinctly lower vibration. And that is the case when you also look at the measurements from the HSE labs. So the declaration from the manufacturers would be quite appropriate in helping you select between these tools, but for you to understand what your employees will be exposed to when they use the tool, then you need some other means of identifying the vibration magnitude for that tool for the purpose that you intend to use it. I will move on now to an illustration developed from a case study carried out by Reactec with a utilities company. The idea of the case study was to create a very detailed understanding of the HAV exposure risk in performing a very specific task. So to gain that knowledge of the specific task, the task was repeated several times over with a number of different people, but using the same tool. The task involved excavating a hole of a particular size in a particular type of road, and this was repeated 11 times over with 14 different people involved in the exercise. The people were deployed in teams of 2 or 3 and given an instruction to share the workload of the task and to excavate the hole. Very detailed measurements were taken, and from that very detailed set of measurements, an typical or an average time to excavate the hole was determined, as was a measurement of vibration magnitude each time that the exercise was carried out, and therefore again an average overall excavations and people for the vibration magnitude experienced during the excavation of the hole. Once the data was collected, it was then therefore easy to establish what the risk would be in carrying out the task. So the task itself carried a risk of 280 points, and therefore if the duty holder was able to share this work between 2 people, he would believe that they would see a risk of 140 points as a highest possible value, and if he were able to deploy them in 3-man teams, then that risk would drop to 90 points. So the duty holder gained the information of this task assessment. When the data was reviewed at an individual level, and for all of the individuals involved in the exercise, we looked at what was the maximum exposure for that individual when digging out any one hole. So all of the holes that they were involved in, what was their maximum exposure? Then there was a dramatic range between the individuals. There was a number of individuals who were well below the lowest possible risk of 90 points. And then at least 5 individuals who exceeded what was considered the highest risk of 140 points. Well, there was 1 individual who actually exceeded the risk for the task in himself. Now, why is that possible? So when we looked at the particular data for this individual, Pete, we were able to determine that he did share the work with a colleague, so someone else was involved in the excavation of the hole, but he was involved in digging the hole for a much longer period than his colleague. In the video footage, it was also able to determine that his use of the tool was inefficient. So the tool was applied to the surface at an angle, which meant that the vibration generated by the tool did not go directly into the surface of the road that was being broken. And in fact, more of the vibration was being reflected back into him as a tool user. So the vibration magnitude experienced by him, again, was much greater than many of his colleagues. And those combination of factors, his skill level in using the tool and the lack of appropriate sharing of the work with his colleague, led him to be a much higher exposure level than all of his colleagues, in fact, and close to the legal limit of 400 points. Now, it's only with monitoring can we actually see that type of behaviour. So this takes us on to what Reactec offer and how this can help you with the challenges of managing exposure to vibration. So the HAVwear product, which is worn on the wrist, actually gives two assessments of exposure to vibration at all times. It collects data, first of all, based on the amount of time that the tool is being used for. So this can be determined by the fact that it's able to sense vibration. And then each tool is attached to each tool that he uses is a tool tag onto which is programmed information, including the expected vibration magnitude for that tool. So this expected vibration magnitude for the tool, which can be a vibration magnitude which complies with HSE guidance and complies to the standard protocols, is used then to develop what Reactec term tool exposure points, or TEB, and is therefore in compliance with regulations. So that's one set of exposure data that the HAVwear is able to bring to you. At the same time, HAVwear also determines exposure points based on a real-time assessment of the vibration magnitude in using the tool. So this is based on triaxial accelerometers in the HAVwear. There is a correction algorithm which corrects for the fact that the accelerometers are on the wrist, and it corrects for the energy that's transmitted between the grip point and the wrist to give you a very good approximation of the vibration magnitude incident at the hand at the time of using the tool. So we use this vibration magnitude with the same trigger time to give you what we term sensed exposure points. And that gives you real additional insight into the actual use of the tool, and the comparisons of the two is what gives you that insight into the tool's condition, the poor use of tools, inappropriate tools, etc. Now, to help clarify in terms of the operator or the tool operator's experience of using the HAVwear, it wouldn't be possible to show them both sets of information. So as a company, you're able to choose what information they say on the screen. In the case of this one here, there's a T, which indicates its tool exposure points. And then in terms of the rest of information that the tool operator will be able to see, he'll be able to see his initials, confirming he's the person using this particular device, his exposure points, and some identification information of the tool that he was last connected to. There's also a traffic light screen in terms of giving him visual indicators of whether he's in the green or moving into the amber or the red. And equally well, he will receive sensory alerts, both beeps and vibrations, which become more intense in their severity as he moves further up the scale from the green to the amber and the red, where green refers to below the action value, amber is where the action value has been exceeded, and red is where the limit value has been exceeded. So to summarise how you might look on using HAVwear to comply with the guidance from the HSE, Reactec refer to Plan, Do, Check, Act. So the planning stage of hand-arm vibration management is your initial risk assessments. And for your initial risk assessments, you would be looking to understand the type of tools that your operator is using and how long they're likely to use them. Perhaps use a ready reckoner to ensure that you're not putting people at risk to be anywhere near, for instance, the limit value. You may choose to also do some compliant measurements of the tool, but this is not necessary for a risk assessment. What you should do is go on to monitor your exposure, your employees' exposure to hand-arm vibration. And to comply with HSE guidance and monitoring, then you can use your TEP points to give you an indication of how appropriate was your initial risk assessment and comply with seeing whether or not, as I say, this is representative. To look even deeper at the topic, Reactec will suggest that you can then use your SEP data. And even the HSE have advised that the comparison of the SEP and TEP data can lead you to see perhaps issues that you wouldn't normally be able to see, such as an operator's proficiency in using a tool and the condition of the tool and its accessories. Importantly in all of this is that the loop is closed and the data that you can collect from your HAVwear, whether it's TEP or SEP or the combination of both, is used to assess that your controls that you have in place are adequate and effective. And if those controls are not effective, then you look to improve those controls and the cycle can go on in terms of continuous improvement of the exposure risk to your employees of hand and vibration. And really just as a means of concluding this section on hand and vibration management, I'll bring you back to the topic of ISO standards and try and clarify some of the information that you may have seen in the marketplace in general. So ISO 5349 as a standard is a standard that defines how to carry out a risk assessment, including the need for the time on the tool and the vibration magnitude. The vibration magnitude can be determined through the use of measurement as one methodology. If it's achieved through the use of measurement, then an instrument in compliance with ISO 8041 should be used. Such an instrument is one that requires a skilled technician to be able to use. It requires a calibrated instrument and it requires the accelerometers to be within 10 millimeters of the grip point of the hand. Such a measurement is not one that can be used for gathering a full day's use of HAV exposure from multiple tools and is therefore is not useful to be able to carry out or to be able to monitor someone's daily exposure to hand and vibration. The type of products which can gather daily exposure to hand and vibration, such as Reactec's HAVwear and other products that Reactec have produced in the fact, are able to help you assess exposure as required by the control of vibration at work regulations, remembering that they look for the probable vibration magnitude as opposed to a measurement of vibration magnitude. But it isn't appropriate to say such devices are compliant to the standards which are listed here. So hopefully that clarifies that topic. I'll move on to a quite different topic now, which is the HAVwear product which Reactec have provided you to be able to manage hand and vibration exposure can also be used to help you with the management of social distancing within the workplace. If you enable the safe distance functionality within the Reactec analytics, basically a HAVwear will alert you if you come too close to a colleague, and again it will emit a buzzing sound or a vibration when it believes that it's a physical distance which is unsafe. This physical distance that is determined based on the Bluetooth signal strength between two HAVwear devices is not a precise measurement of distance, and it will be affected by how well the two devices align and whether or not the body becomes in the way of the detection between two devices. Reactec do believe that by having a wrist-worn monitor, then the possibility of missing proximity by another device because of body blocking is actually minimized because of the effect of the ability of your hands to act as a bit of an antenna. And in terms of the distance at which it's detected, I'll talk of this a little bit more when we get into the settings for the safe distance facility. When the safe distance functionality is switched on, if people come into close proximity and they come into that close proximity for a period of time that's concerning, and we consider those as being moderate proximities or sustained proximities, then each day there will be a daily email to alert you of these instances. In addition to that automatic email, reports are available within the system to give you the detail of the proximity detections. So first of all, there's a workforce summary report, which allows you to see information over time and see information between different projects and different periods to basically allow you to assess whether or not your social distancing management procedures are effective. The type of information that we're collecting in the way of proximity, so for instance, the workforce contact reports, what this does is it lists for every individual how many days they've used the equipment in that period, how much contact time have they had with others, and what is the daily average. And then it distinguishes between short, moderate, and sustained contact between these individuals, which is time periods which you can set up. So typically, customers would consider short as being less than a minute, and for that to be inconsequential and not a problem. Whereas moderate, they might consider as to be greater than 1 minute, but less than the sustained period, which is typically 15 minutes. And you would spend your management efforts managing your moderate and sustained, and be very much wanting to ensure that there are no sustained detections. With this sort of information, you can also click into the detail with these blue buttons, and that gives you all of the detail that you require for contact tracing between individuals. And again, you can see it in a summarised manner in terms of overall time and what days, which individuals were interacting with which other individuals. And as with all Reactec reports and data within the analytics, if these are reports that you want to see on a regular basis, you can also enable these to be automatically sent to you. So just by way of concluding this PowerPoint, I will just finish with a few messages of how more broadly Reactec's roadmap in terms of technology and developments may well be something that can align with your future needs. So basically, Reactec are on a journey to gather more and more types of health risk data from the workplace into our Reactec Analytics data platform. So we've looked at the sort of information within this presentation available from Reactec centres, including vibration and proximity between individuals. With vibration, there is also an ability to help people and how to use tools most effectively. And from the proximity, we're moving into broader perimeter type detection. We also have lone worker type support functionality from what we call a razor device, where you have a panic function, it will automatically detect man down, and there is a check-in, check-out functionality. Beyond this, we are actively engaged with other suppliers of health sensors, including noise, dust, and cable avoidance, and are looking to gather the data from these third-party devices and again supply it in a very consistent and useful manner within our Reactec Analytics platform, allowing you to have an aggregated picture of your workforce. So as we say, the centre to all of this is the Reactec Analytics in terms of its ability to turn personal risk data into intelligence that you can then take action with. So all of the data is displayed in a manner which you can then see clearly the controls that you may need to put in place to lower the risk of the employees in the workplace. By gathering the data in such a powerful and automatic way, then it improves your operational efficiency in terms of the management of these risks within the workplace. By the introduction of products such as Razor, it means that real-time access to data comes into play, allowing you to see what's happening in the workplace as people are live and active out in the working environment. And as a reminder, in all things, we look to make that data things that you can then take action on, and the record of those actions can also be put within the system. We've had a consistent and singular approach within Reactec to how we gather what is personal data, and that's a way by which each device is assigned in a very simplistic manner to a person at the start of the working day and returned, which means that at all times as an employer, you can be assured of the availability of the devices and the devices being in the right condition to be used the next day by other people. And basically, we see this as a future-proofing, if you like, for your investment of being able to look to the longer term in the use of your current deployment of Reactec for hand-arm vibration, with the addition of other sensors and other future applications. This is just a few illustrations of the type of data that's available within our analytics. So this is the live dashboard showing information of data that's out in the field. We have hand-arm vibration data, we have noise data, we have social distancing information, and then active alerts and alarms when either of these systems are calling for amber or red events. And this allows you to manage your support of individuals in the field. The live data also comes with GPS location information. Again, this comes from the use of the Razor device, which allows you to not only know the people that are in the field that may need your support, but where they are and therefore who might be in the best position to support them. And finally, as I mentioned earlier, the intention from Reactec is to make sure that this data is supported with your ability to record your actions to improve the performance of the data. So we have control measures and we have intervention logs, which allow you to demonstrate that you're taking action to improve the health risks that your employees are experiencing. So in summary, the key benefits that hopefully you will gain from your investment in Reactec, you will be able to meet the requirements of the regulations and also the HSE, and most importantly, prioritising and verifying the effectiveness of your controls aimed at reducing your risk as low as reasonably practical. And those controls will be data-driven improvements, which ensures the efficiency of the work that you do in terms to design and prioritise your control activity. You do have robust and credible data that can be used in the case of civil litigation. It has stood the test of time in terms of GDPR compliance and for the use of defending civil litigation cases. And then finally, in using Reactec's technology to manage your employees' health risks, we would suggest that you're turning a generic risk assessment into a personal assessment of what's happening to that individual. And remember the example of Pete. In Reactec's experience, in the variabilities that come to play in the use of manual tools, there is always a Pete who is at much greater risk than you expect him to be. And only with monitoring can you find that risk and then manage that risk. So that concludes this PowerPoint, and I thank you for your attention.